Everything around us is made of something, right? Trees, rocks, even the air we breathe. We call these things matter, but what is matter made of? For a long time, we thought atoms were the smallest building blocks. Then we discovered that atoms are made of even smaller particles, protons, neutrons, and electrons. And guess what? Protons and neutrons are made of even tinier particles, called quarks. These tiny particles are a fundamental part of our universe. Quarks are so small we can't even see them with the most powerful microscopes. But we know they exist because of how they interact with other particles. There are 6 different types of quarks, and they have pretty interesting names: up, down, charm, strange, top, and bottom. Each quark has a different electric charge, which determines how it interacts with other particles. Some quarks have a positive charge, and some have a negative charge. Another important property of quarks is their spin. It's a bit like how the Earth spins on its axis. The idea of quarks first came about in the 1960s. Physicists Murray Gell-Mann and George Zweig were trying to make sense of the jumbled mess of particles they were finding in their experiments. They proposed that these particles weren't fundamental after all, but were made up of even smaller, more fundamental particles. They called these particles quarks. At first, many scientists were skeptical, but then experimental evidence began to support their existence. In the 1990s, physicists at Fermilab finally discovered the top quark, the last of the 6 quarks to be found. This discovery was a major triumph for particle physics. The discovery of quarks revolutionized our understanding of the universe. It helped us understand how matter is put together at the most fundamental level. Today, scientists are still hard at work, trying to unlock the secrets of quarks. We're building bigger and better particle accelerators to smash atoms together at even higher energies. By studying the aftermath of these collisions, we can learn more about the properties of quarks and the forces that govern their behavior. Who knows what other mysteries the universe holds? Perhaps one day we'll discover even smaller particles than quarks.